Snarge is, it's a word that's unique to our lab. We use it to identify the bird ick that's scraped off of the airplane, and it's really snot and garbage, spelled S-N-A-R-G-E, snarge. The function of our lab is primarily to identify the birds or the snarge that comes off of the airplanes after birds and airplanes collide. Studying bird strikes and knowing the species of birds that are involved in these events is key to a lot of different important things that go on the airport environment. Once they know what the bird is, they know why it's there. What's it eating? Is it resting? What's it doing on the airport? And what they can do to mitigate that habitat there to keep the birds and the airplanes apart. Last year, we identified over 14,000 bird strike samples, and we used forensic-like techniques to identify these puzzles. We might use the whole feathers one day to match up the color or the pattern or the texture. Another day, we might rely on the DNA analysis for our major part of our identification work. In this room, we have 500,000 specimens of birds that acts as our library that we can use to match up these unknown samples.
I had 3 really nice feathers come out of that bag of ick. I noticed a beautiful black and white pattern that came out. And when I see nice black and white stripes on a big bird, I'm immediately starting to think bird of prey. And then I had a nice flat little feather. It was white with a black spot. And I'm also starting to think about where on the bird's body does this feather go. When I see a nice small flat feather, I know that this is going to be an underwing covert. So it's going to sit in the bird's armpit to make a nice flat surface for that airfoil wing as it flies. So I went to the collection, I got out a bunch of candidates, and I started to try to make matches. Red-tailed hawk is usually one of the most common birds of prey we see, so I took out my helpful red-tailed hawk specimen and I tried to make a match. And it's close, but it's not quite. But I had a clue that something was fishy. So I have an osprey, which is a fish-eating bird of prey. And when I took out the osprey, I matched up this nice underwing covert is the right shape, it's the right size, it has the right pattern. Working here, having specimens from every state in the United States of America, specimens from across the world that I have at my fingertips in this room means that I really don't think I could perform this work anywhere else. I'm going to take my sequence and I'm going to put it into the Barcode of Life database, which is a DNA library, much of it generated from the specimens in this collection. The computer is going to match up my sequence, my unknown sequence, to the big library of sequences. And the result that it gives me is a 100% match to osprey.
Our work is important because it makes the sky safer for all who fly, birds and people. I mean, when the bird hits an airplane, the bird is not going to be the winner. And so by identifying the species that cause these problems on airports, we are able to give the biologists information to keep those birds away from the airport, and thereby saving the birds.